All right, guys, this is the root mean square. All right, this is how we're going to find the root mean square. So our equation is root mean square is equal to the square root 3 times r t over the molecular mass. Now, a couple of things that we really need to keep in mind here are these two things. This is going to be the new one, and our molar mass must be what in kilograms per mole. As explained in the other video thing that I did, right? So that's our equation. You got that from the notes. It's really, these equations are not that difficult to work with, man. Because look, the first thing that we've got from our sample there is we have helium. And since I need to have the molar mass of helium, I'm just going to use the periodic table. It is 4.003 grams per mole. And nitrogen is going to be equal to 20.02 grams per mole. And also, don't forget, look, do not forget, man, like this is like, remember N over down, don't forget the H. Y'all, that's a simple trick to remember diatomic, because nitrogen is one of your diatomics. You cannot forget that, okay? So that's going to be really important that you remember all of your diatomics. They're going to assume that you know that. Oh, the other thing they gave you was temperature. 25 degrees Celsius. We know we're just going to add 273.15 to switch it to Kelvin. 2789, so that's 290. 3 and 5 is 8.15 Kelvin. All right. So there's our variables. I mean, I don't think we even need to do much of a roadmap with this. Like, it's all like pretty much cut and dry, right? We have all of our variables. We have 3. We're going to use the new R. We have our temperature. We have the gram formula mass. That will give us the root mean square. Units for this is going to be meters per second, because those are the base units to measure speed or velocity, or whichever one you want to call it. All right, so let's do helium first. Okay, so for helium, the root mean square for helium is going to be equal to the square root of 3 this R is 8.314 times go like this, times temperature, 298.15 divided by the gram formula mass. But remember, because we're using this different R, my gram formula mass has to be in kilograms per mole, which is why we like the metric system, because we got to convert grams to mole into kilograms per mole, which is silly. Not really. Look, I mean, when you go from grams to mole, all you have to do is move the decimal place to the left 3 times, right? So here's how we're going to do that. We're just going to go, this will just be 4.0003 times 10 to the minus 3. There, I just moved the decimal place over 3 times and changed it to kilograms per mole. Don't we just like the metric system now, right? Because that's all you got to do. So for here, for your gram formula mass, down here, instead of using the regular 4.003 right off the periodic table, you just add times 10 to the minus 3. You know, mathematically moving it to the left. So down here, I put 4.00 e to the minus 3. Slap all your units in there, do your math, blah, 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 like, you know, your mathy thing. Use your calculator, you knuckleheads. When I'm done with that, my answer that I got was 1362.6. And since up here I've got 4 significant figures, this will be equal to about-ish 1.31, 3, 6. I'm going to round that up to 3 e to the 3rd meters per second. Dig how that works? The tricky part of this is typing it into your calculator properly, which I know you're going to do because that's what I tell you to do. Actually do the work with your calculator. Now the next one, the root mean square for nitrogen, if you can believe it, is going to be very, very similar to the root mean square for helium. All right, the root mean square for am I on camera there? There you go. So the root mean square for nitrogen is going to be equal to the square root of 3 times our new gas constant that we're really only going to be using for the root mean square calculations, to be honest, times temperature. Oh, and this time, let's go back up here. The gram formula mass is 28.02 grams per mole. But remember, because of this R, because we're using this R has kilograms embedded in it, in the units of joules. So we need to come up here and change this to kilograms per mole. And I think you know how to do this, which is why we love the metric system. There, I just did my unit conversion. So I'll come back down here to my root mean square calculation. What did I just write? 28.02? Calculator it, guys. Which I'm gonna round to, I've got 1, 2, 3, 4, 1, 2, 3. I'm just gonna go to 4 significant figures here. So 1, 2, 1, 2, 3, 4. 0.150 e to the 2 meters per second. You guys get what I'm saying? I didn't write the units in here just because the units get really messy with this, and I just want you to focus on like getting the variables in the right place and doing the math. But that other little video should show you you should get an idea of how all the units cancel each other out, particularly with this bad boy right here. All right, if you have any questions, shoot me an email or a comment in the classroom. I miss you guys.